Welcome you all to Department of Collegiate and Technical Education. This video session number 6 is the continuation of video session number 5 of Engineering Mechanics and Strength of Material course for third semester in Civil Engineering Department. I suggest before viewing this video, please watch the session number 5 video for better understanding. We move to the next slide. Table of content. Recap. In the recap session, the video session number 5 has covered the moment, couple, and difference between moment and couple, and how to solve the problem in coplanar parallel forces, how to find the resultant in coplanar parallel forces, coplanar concurrent forces, and coplanar non-concurrent forces. Now, in this video session, we are going to study the numerical problems, how to calculate the resultant and direction in coplanar parallel forces, coplanar concurrent forces, and coplanar non-concurrent forces, and some multiple choice question for assessment of this above topic. Resultant of number of coplanar forces. When there is a number of coplanar forces, sigma h equals to, we have to calculate sigma for resultant. We need to calculate sigma h and sigma h b. The sigma h is the each horizontal component of the force, given force, concurrent force, and F1, F1, F2, F3, where force are where concurrent force will be in this manner: x-axis and y-axis, z-axis. If suppose this is F1, this is theta, F1 cos theta will be the first component, and this suppose this force is F2 and theta is this one, and F2 cos theta 2, F2 cos theta 2 will be the next one. In similar way, F3 cos theta and F3, F4 cos theta 4, F3 cos theta 3, and F4 cos theta 4 for number of forces. And we have to find the sigma h and sigma v, vertical component and horizontal component, and we have the summation of horizontal component, which is sigma h. So summation of vertical component will be sigma v. Next, now the resultant force will be calculated with formula R is equal to sigma square root of sigma h square plus sigma v square, and the direction of the resultant with respect to axis theta axis is calculated in the formula tan theta is equal to modulus of sigma v is equal to sigma v divided by sigma h, modulus of summation of vertical component divided by summation of horizontal component. Modulus indicates that we have to neglect the signs. Positive and negative signs should be neglected. Theta can be calculated by tan inverse of sigma h by sigma v by sigma h. We know that quadrant, we have already gone through this in the previous session. Now I'll repeat. In first quadrant, plus both are positive, and second quadrant plus and minus, vertical component is plus and horizontal component is minus, negative, and in third quadrant both are negative, and fourth quadrant vertical component is negative, horizontal component is positive, where in this case of tan theta we have to neglect this signs while calculating the directions theta. Okay. Next is the resultant for parallel forces, where number of parallel forces are there. Parallel forces which is in vertical direction, where we have to calculate the horizontal component, vertical component. Here the horizontal component will be 0. That's why only vertical component will be calculated, and resultant will be calculated by this formula, same formula as we saw in the previous slide. Next, resultant will be found as there is no vertical force, horizontal force here. The vertical force will be all F1, F2 on summation of all these forces, F1, F2, F3, of course. For now, simple problems on forces. First one, Find the resultant force of the given coplanar for parallel forces. We are in this figure, the 40 kilonewton, 30 kilonewton, and 20 kilonewton, and 10 kilonewton are the parallel forces. The 40 kilonewton, 20 kilonewton are like parallel forces, and 30 kilonewton and 10 kilonewton are in the same direction, which is also like parallel forces, which is in 0.3 meter and 0.4 meter and 0.3 meter apart. Each has a distance apart. These forces have a distance apart. Now we need to calculate the resultant first. Before calculating the resultant, we have to calculate sigma h and sigma v, where sigma h is a summation of horizontal force, where there is no horizontal force here. We can see here only vertical forces are there. Then no need to calculate the horizontal force. Sigma h will be 0, and sigma v will calculate sigma v to find the resultant. Sigma v will be equal to directly, as I said earlier, resultant that since the sigma h is not there, square root of sigma v square will be directly the formula. Since sigma v equals to 40 kilonewton plus minus 30 kilonewton minus plus 20 kilonewton minus 10 kilonewton will be the sigma v, where sigma h equals to 0, r equals to directly sigma h square plus sigma v square, where sigma h is 0, directly sigma v square is equal to r is equal to sigma v. Here sigma v directly it can be written as also sigma v. I clear it. This will be the sigma v. Directly it can be sigma v. Our resultant is equal to sigma v, f1, f2, f3, the summation of all the vertical forces. Okay. Next, resultant will be equals to f1 is 40 kilonewton positive direction, which is upward direction. Now the 30 kilonewton is downward direction negative, which is downward direction, and 20 kilonewton upward direction, which is again positive, upward direction is positive. Next, lastly 10 kilonewton, which is downward direction, is negative. The summation of this total will be equal to 20 kilonewton positive, 20 kilonewton. 20 kilonewton. Now the resultant will be we have having the direction upwards. We are unknown of the distance where it is lying. It may be lying from A to D. Within A to D, it will be lying anywhere. We have to calculate that where it is exactly the direction of the resultant force. Now we know that the magnitude of the resultant we know 20 kilonewton. 20 kilonewton magnitude we know, but we don't know where it lies between A and D. So to calculate that we have to 20 kilonewton is upward direction. We have to take moment about A. To taking moment about A here, moment about A, to find the direction to taking moment about A, moment about A, all the force into perpendicular distance, summation of all one by one will take. Moment about A will be equals to 40 into we know the definition of the moment. What is moment? Moment is product of force and perpendicular distance. If we consider force one by one, this force is upward direction, is moving in upward direction, but it has no perpendicular distance. The rotation of point of rotation and distance to the force is 0. That's why this can be neglected, because it's passing through the point A only. There is no perpendicular distance. Perpendicular distance is 0. That's why no need to take the first forces, as it is 0. I'll skip this, and next second force is 30 kilonewton. I'll write first force into perpendicular distance. 30 kilonewton into distance is 0.3 meter, which is a negative direction. Now next one is 20 kilonewton. I'll explain once again 30 kilonewton. This is 30 kilonewton. We are taking the moment at point A. Distance from A to B is 0.3 meter. It is the perpendicular distance. 30 into 0.3 is the answer, minus because it is downward direction. Next, the 20 kilonewton. Next force is 20 kilonewton. 20 kilonewton into perpendicular distance C from A to C, 0.3 plus 0.4 plus 0.75. 0.75. 0.75. 0.75. Then the sign is negative, sign is positive, upward direction. Then 10 kilonewton, 10 kilonewton, third force is 10 kilonewton, 10 kilonewton into total perpendicular distance 0.3, 0.6 and 1.05, which is downward direction, that is negative. Calculate it by adding each one of them, we'll get okay. Moment, we have taken the moment here. Okay, there is taken the moment. Still one force is there. I'll write once again. 40 into 0. Here 40 into, I'll show it here only. 40 into 0, 40 because it passes through the same point, and B 30 into 0.3 and 20 into 0.75 and 10 into 1.05. Okay, the law of transferability force can be applied here, where resultant moment will be equals to the summation moment. Resultant moment will be equals to summation moment. Or else moment about taking moment about point A, assuming that resultant is also a force which is acting here somewhere here, we don't know where it is, but taking the distance between the from point A equal to x and adding this, resultant is upward direction, we know result is upward direction, we have calculated resultant is upward direction. The resultant into x, resultant 20 kilonewton, resultant 20 kilonewton, resultant 20 kilonewton with the upward direction positive into x. We have to assume the x direction, we don't know where it lies, we have to calculate this x, that's why x into x is 20 kilonewton. Moment about the any point will be equals to 0 if we consider the resultant also. This is again the law of transmissibility of force. If now the equating the moment is equals to 0, then we get this equation, and solving for the x due to equilibrium condition, moment is equal to 0, and solving for the x equal to 4.520, 0.225. Resultant is 0.225 from the point A. From point A. Resultant is here, red arrow mark indicates that it is a resultant. It is 20 kilonewton magnitude with a distance of 0.225 meter from point A. This is how we have to calculate the resultant and its direction. Next we will move to next problem. Find the resultant force of the given flow figure. We have to calculate the resultant force of this coplanar concurrent force, where each force has an angle with the x-axis. Now we have to calculate. Now we have to resolve the each forces. For example, 150 kilonewton. If we resolve the 150 kilonewton, it will be resolved in two ways. This is 150 kilonewton. 150 equal to f is 150 kilonewton. We know that theta is 30 degree with respect to x-axis. Then vertical component will be 150 sine 30 degree. Sine 30 degree. Then this one horizontal component will be 150 cos 30 degree. Cos 30 degree. Let's calculate the vertical component first. All the vertical component here. We know it will be resolved in every force can be resolved in this manner. Two horizontal perpendicular horizontal component, as we have learnt in the resolving of forces. Sigma v, let's take the 150 kilonewton, which sigma v will be vertical forces. All vertical forces are sigma v, vertical component will belong to vertical component, and horizontal force will belong to horizontal component. Next 150 sine 30, this 150 sine 30. Next is this one 200 vertical component, 200 sine 30, 200 sine 30. Yeah, 200 sine 30. Next vertical component is here. 80 sine 60, but 80 sine 60, but it is moving in downward direction, that is negative, minus 80 sine 60. Then here in fourth quadrant, vertical component, this is vertical component, minus, again the vertical component is minus here, downward direction, the arrow is downward direction. Here it was positive, both are positive, vertical component are positive, the positive sign, and vertical component is negative here, minus 180 sine 45, minus 180 sine 45, yes. By calculating this in the calculator, we get minus 21.56 kilonewton, minus 21.56 in the, because all the forces are in kilonewton, it will be in kilonewton. Then horizontal component, again we'll resolve horizontal component. We have resolved it. 150 cos 30. First force will be 150 cos 30. Next, here, next quadrant force, this one 200 cos 30, 200 cos 30, but it is in right side direction. This was in positive direction, this is negative, minus 200 cos 30, yes, minus 200 cos 30. Next, here also it is negative direction in third quadrant, 80 cos 60, 80 cos 60, 80 cos 60, minus 80 cos 60, that's right, minus 80 cos 60, yeah. Next is, it is in positive direction, 180 cos 45 degree, 180 cos 45 degree, at 180 cos 45 degree. I'll erase all this, 180 45, and if we add all this, 43.97 kilonewton, minus 26, minus 26, 21.56 kilonewton, minus 21.56 kilonewton. This is 43 plus 43. The sign is very important here. First, plus 43.97 kilonewton. Then the resultant force we have to calculate. R is equal to sigma h square plus sigma v square. Sigma h square plus sigma will be, we will get resultant. Sigma h square plus sigma v square is equal to square root of sigma h square plus sigma v square is equal to resultant R. The R equals to, we have to substitute the h and v, then we'll get the resultant 48.97. We know the 48.97 is the resultant. We have to analyze it now, where actually the resultant appears, either in first quadrant, second quadrant, third quadrant, or fourth quadrant. Which quadrant it lies, we have to find out that. So for that, we have to know the signs of sigma v and sigma h. Sigma v is negative and sigma h is positive. In first quadrant, both will be positive. Sigma v and sigma h is positive. In second quadrant, sigma v is positive, sigma h is negative. In third quadrant, both are negative. In fourth quadrant, sigma v is negative, sigma h is positive, and this is similar. This indicates that my sigma v is negative and sigma h is positive. It's in third quadrant. This in third quadrant. sorry, fourth quadrant. It's in fourth quadrant. This quadrant here, it lies in fourth, this quadrant, somewhere here. Now resultant lies somewhere here. We have to calculate the direction with respect to x-axis. How much, what is the angle which makes the resultant, what is the angle which makes the resultant, we have to find out it now. Then for that, theta is equal to tan inverse of tan theta is equal to sigma, modulus of sigma v by sigma h. That is the formula. Theta is tan inverse sigma v by sigma h. Sigma, we have to substitute. Sigma v is 21.56. We have to neglect the minus sign because modulus, we have put the modulus. 43.97 is the sigma h, and we get the, by calculating it, we'll get the theta is equal to 26.12. You can write in degrees also. 26 degrees, 7 minutes, 13 seconds. We have come to know that direction, magnitude, direction. What is the direction of resultant, which is 26 degree from x-axis. 26 degree from x-axis. 26 degree 7 minutes and 13 seconds. 26 degree 7 minutes 13 seconds. The resultant force R equals to 48.97 kilonewton. 48.97, all are in kilonewton. You have to, the units are very important here. All are kilonewton. Forces are in kilonewton, and direction is in degrees. Okay. Next, the quadrant in which fourth, it lies in fourth quadrant. This quadrant, that's why the resultant comes in fourth quadrant. Yeah, fourth quadrant, and angle is 26.12 degree. I hope you understood. We'll move to the next problem. Composition of force, or it's again the problem based on the composition of force, where will solve the coplanar concurrent force in the form composition of force, or by resolving and composition of force. Problem: 50 kilonewton, 60 kilonewton, and 40 kilonewton. In previous problem, we have solved the problem which was divergent force, concurrent force, which was moving away from the point of intersection. But here it is convergent kind of forces. Here, if we resolve the forces like this will be horizontal force and vertical force. Horizontal force will be in this direction negative, minus 50 cos 30. First we have to resolve all the forces. Minus 50 cos 30. In case of vertical component is downward direction, again minus 50 sin 30 degree. Minus 50 sin 30 degree. Let's horizontal, every component of force is divided into vertical and horizontal component. Vertical component and horizontal component. Vertical component, we minus 50 sin 30. We have written it minus sin 50 sin 30, which is minus 25 kilonewton, and horizontal component minus 30 cos 30. 50 minus 50 cos 30, minus 50 cos 30, minus 50 cos 30. That's it. Next we'll go to the 60 kilonewton. 60 kilonewton, vertical component will be like this, horizontal component will be like this. If we resolve the forces, the vertical component is moving in downward direction, as the force is in this direction. Downward, it is moves in downward direction. Then the vertical component will be 60. Very be attentive. 60 sin, the angle we are taking now, it's very important. Here there is 60 degree, but as per the definition of horizontal and vertical component, what we divide, horizontal component is f sin theta, sorry, f cos theta, horizontal, vertical component f sin theta, horizontal component f cos theta, where theta is with respect to x. Theta is always take with respect to x. If sin theta, if we write 60 degree, it will be wrong, because if you are taking sine, then it will be 60 is wrong, because it will be according to this formula, theta x with respect to x. If this is with respect to y, this is with respect to theta. 60 degrees with respect to vertical axis. What it is showing with respect to vertical axis, but we have to get the angle with respect to x axis. Then it is very simple to calculate the angle with respect to x axis, where the total is 90 degree, the quadrant is 90 degree, and minus 60 degree is 30 degree. Then 60 sin 30 degree, it goes in downward direction, this is negative. Like this. Let's see. 40 cos 25. We have went to clockwise. Okay, and let's go clockwise only. If you resolve this force, this will be horizontal force will be this one, vertical force will be, it will be resolved like this: vertical and horizontal force. Horizontal vertical force V is equal to, here V is equal to F sin theta, and theta is with respect to x axis, or we can, here we have changed F, that means 40 sine 60 degree. We can write FP 0.60 or 40 cos, sorry, not sine 50, 65 degree, 65 degree, sine 40 sine 65 degree, 40 cos 25 degree. Okay, 40 cos 25 degree. Let us repeat the 40 kilonewton force once again. This 40 kilonewton force can be resolved into vertical component and horizontal component. The vertical component, vertical component is positive. It can be resolved in F sin theta means 40. You have force is 40 sin theta. It should be with respect to x axis. Theta with respect to x axis, but here theta is with respect to y axis. 90 minus 25 degree. This angle will be 65 degree. Then 40 sin 65 degree. 40 sin 65 degree. 40 sin 65 degree, that is 36.25 kilonewton. Now horizontal component is negative direction. It is in negative direction. Then minus force is 40 kilonewton. 40 horizontal component F cos theta. 40 cos theta is with respect to x direction, with respect to 65 degree. Minus 40 cos 65 minus 40 cos 65 is equal to minus 16.90 kilonewton. Next force is 40 kilonewton. This force, which can be resolved in horizontal component, vertical component and horizontal component, which can be resolved in horizontal component. Let's solve first vertical component. Vertical component F sin theta. F is the magnitude of the force is 40 kilonewton. F sin theta, F is 40 sin theta. Theta is with respect to x axis. With respect to x axis, angle is 20 degrees. 40 sin 20 degree, which is moving in upward direction, positive. Plus 40 sin 20. Plus 40 sin 20, which is equal to 13.68 kilonewton. Next, horizontal component, like in F cos theta. Horizontal component is F cos theta. Theta is with respect to x axis, and F is 40 kilonewton. Cos theta is 20 degree. 40 cos 20. This is positive direction because it is moving in right side. Positive. Plus 40 cos 20 is the next H3. 40 cos 20 degree, which is equal to 37.58 kilonewton. Next, last 60 kilonewton force. We have resolved 50 kilonewton force, 40 kilonewton force, 40 kilonewton force, and here also in third quadrant 40 kilonewton force. Now 60 kilonewton force. When we resolve the 60 kilonewton force, it can be resolved like this: vertical component and horizontal component. Let's calculate the vertical component first. Vertical component moving in downwards, which is negative direction. Formula for vertical component is F sin theta. F is the force 60 kilonewton. F is 60 sine theta. Theta is here, theta given here. We have to take the theta with respect to x-axis. Here it is given with respect to y-axis, 60 degree with respect to y-axis. When with respect to x-axis angle is 30 degree, 90 minus 60 is equal to 30 degree will be the angle with respect to x-axis. That we have to take always we have to take the axis with respect to x-axis. Minus 60 degree sine 30 degree. Minus 60 degree sine 30 degree will be the next. Minus 60 degree sine 30 degree, which is equal to minus 30 kilonewton. Now let's go to the horizontal component. Again, horizontal component formula is F cos theta. F cos theta. F is 60 kilonewton. 60 cos theta is here with respect to x-axis. Always with respect to, you keep in mind, always whatever the angle we have, we will resolve the force. Horizontal H equals to F cos theta, or vertical component is equal to F sin theta. Both are with respect to x. Keep this in mind. Always take the angle with respect to x. It will be easy for you. Then 60 cos 60 degree, cos 60 cos 60 degrees. We should not take 60 degree as it is with respect to y-axis. We have to take the angle with respect to x-axis. 30 degrees angle is with respect to x-axis. Then 60 cos 30 degree is the component. It is moving in the right side direction. That's why positive. Then next, let us see, positive H4 is equal to 60 cos 30. It is 51.96 kilonewton. We have resolved all the forces starting from the 50 kilonewton, 40 kilonewton, and 40 kilonewton and 60 kilonewton. We have resolved in all forces. Now calculate all the forces. Summation of all these forces will get sigma V, and summation of all these forces will get sigma H. Now calculate the sigma V and sigma H by adding all this. We will get minus 5.07 kilonewton in sigma V and minus 29.34 kilonewton. Minus 29.34 kilonewton in sigma H. Now only we can decide resultant what will be the resultant direction, with which quadrant it lies. Minus and plus. Minus 5 and plus. V is minus and plus. We know first quadrant both are plus. Vertical here, vertical component plus, negative minus. Both are minus, minus and plus. Vertical component minus. This one is positive. We can understand here only. This is x-axis here is this is positive line. This is negative line. This is positive line and this is negative line. Here vertical. This is vertical. Take this quadrant vertical. It is positive, and here also positive. Here vertical positive, negative. I will write always vertical first and then horizontal. Vertical, horizontal. Now here the vertical component is negative and horizontal component is positive. Vertical component negative and horizontal positive is in fourth quadrant. Resultant will lie here. Resultant will be in fourth quadrant. We can judge before the resultant is calculated. Now we will calculate the resultant. What is resultant? Resultant is formula is sigma. Resultant is sigma h square plus v square. Sigma or sigma h square plus sigma v square. Square root of sigma h square plus sigma v square. Sigma h square plus sigma v square. Minus 507 sigma v and sigma h is 29.34. We have calculated it in below. Substitute that in the formula and we will get the resultant. Resultant is 29.77 kilonewton. Resultant is 29.77 kilonewton. Now resultant is 29.7 kilonewton. It lies in the fourth quadrant. It lies in the fourth quadrant in this direction. Now we need to calculate what is the we know that it lies in third quadrant, but what is the angle where exactly it is positioned? We have to position it. What will be the angle with respect to the x-axis? We have to know. For that, there is a formula where tan theta is equal to sigma v by sigma h. First, tan theta is equal to sigma. Let us draw it resultant separately. It is 29.77 kilonewton. Its horizontal component is 29.34. We have calculated it here. This is the total horizontal component, and the vertical component minus 5 calculated here. And we have to calculate now for the direction, that is what is the direction, what is the angle theta. For that, tan theta is equal to sigma v by sigma h, where sigma v equals to 5 minus 0.07, that it is a modulus where we have to take we have to ignore the signs of positive and negative signs. 5.07 divided by 29.34, where the theta will be 9.803 or nearly equal to 9 degree 48 minutes. The angle theta is equal to 9 degree 48 minutes. Or here resultant force which is moving in this direction is angle is 9 degree 48 minutes. 9 degree 48 minutes. Next problem, find the resultant force of coplanar non-concurrent forces. Coplanar non-concurrent forces. What is coplanar non-concurrent forces? The coplanar is force which is lying on all the force which is lying on same plane. Non-concurrent forces, concurrent forces are which intersect point is similar. These are concurrent forces which intersect. We have solved the two problems of concurrent forces. Now non-concurrent forces. Non-concurrent forces which does not lie on does not intersect on single point. All the forces will not intersect on single point. This is the concurrent forces example which is not intersecting on all the forces are not intersecting. Any two forces are intersecting here. All the forces are not intersecting at single point. 30 kilonewton. This is vertical force. 30 kilonewton is vertical force, and 50 kilonewton is also vertical force. 20 kilonewton is horizontal force. 10 kilonewton horizontal force. No, there is no inclination for the any angle. It is directly. We can. There is no necessity of resolving the forces as it directly indicates. This is horizontal. This is vertical forces. This is horizontal forces. This is vertical force, and this is horizontal force. And directly we can include in the formula. No resolving the forces. Then h sigma h equals to sigma h is equal to 20. This force is horizontal, which is moving in the right side direction, 20 kilonewton, 20 kilonewton plus 20 kilonewton, and minus 10 because it is moving in left direction, minus 10. 20 minus 10 is equal to 10 kilonewton. Sigma h is 10 kilonewton. Next, we'll find sigma v. Sigma v equals to vertical force is 30 kilonewton, which is moving upwards, then positive upward moving is positive, and it is 50 kilonewton moving downwards, minus 50 kilonewton, minus 50 kilonewton, which is equal to minus 20 kilonewton. Vertical force is minus 20 kilonewton. Let's see, minus 50 kilonewton, this is minus 50, and plus 30, and minus 20 is the sigma vertical component. Vertical component and horizontal component, as we know the horizontal and vertical component, we can find the resultant by the formula R equals to square root of h square plus v square, or sigma h square plus sigma v square. Let's calculate sigma h square, find the resultant sigma h square plus sigma v square, square root of sigma h square plus sigma v square. We'll substitute the sigma h square and sigma v square. Sigma h square is 10, sigma v square is minus 20. Then the resultant square root will be 22.36 kilonewton. Resultant will be 26.36 kilonewton. And the direction of the force, where will be the direction of the force? If you consider this as a center, this as a center, the direction we know that. Again, I'll draw an axis here. I'll draw an axis, x-axis and y-axis. To know the direction of the forces, x-axis and y-axis, and 22 kilonewton is the resultant force. Where it lies, we have a question here. Where does the resultant force lies in the question? No, lies in the problem. Then we have for that only we have drawn the x-axis and y-axis. The 22.36 kilonewton is a resultant force, where this 22.36 kilonewton resultant force, we have received it from the horizontal and vertical component, where horizontal component is positive and vertical component is negative. Vertical component negative and horizontal component positive in which quadrant it lies. Let us see once again. Here both are positive. Here vertical component is positive and horizontal is negative. Both are negative. Vertical component is negative and horizontal component is positive. And that means the vertical component is negative. Vertical component negative and horizontal positive in the third quadrant. we can draw the resultant force somewhere here. We cannot draw directly, but it is not to scale. So I am drawing here as it lies in the third quadrant. The resultant of all four forces, 20 kilo, 30 and 10 and 50 acts. If it acts simultaneously, then the resultant will be in this direction. We came to know that. Now, how to calculate the direction? In which direction? It may be in the direction in the third quadrant. From here to here, it is 90 degree. In exactly where it is situated, that we have to find out. For that, tan theta is equal to tan inverse of sigma v by sigma h. Sigma v by sigma h. Substitute the sigma v by sigma h here and 20 by 10. Then we'll get 63 degree. 63 degree. 63 degree. Then if we draw the axis, nearly 60 degree is resultant force, which is 22.36. Will not visible. Once again, if it is assume this as axis and force moves in this direction, which is F is equal to 20, sorry, R is equal to, resultant is R is equal to 22.36 kilonewton, and angle with respect to x axis is 63 degree 43 minutes. Resultant force acts in this direction. I hope you there is no doubt or clear. Thank you. 63 degree. Now let's start multiple choices for assessing today's sessions topic. Multiple choice. First question: the resultant of two forces P and Q acting along the same straight line and downward direction, straight line in downward direction. Resultant two forces P and Q acting along the same straight line in downward direction is given by downward direction is here, and P is in same direction as P and Q. Will move in P and Q will be in this direction. P and Q will be in this direction with same direction we have to add, but P is moving downwards. It is minus P, and it is also moving downwards. And Q also minus Q. Minus P minus Q is the right answer. Minus P and minus Q is the right answer. Second question: in equilibrium, body will be in static condition. True or false? Yeah, equilibrium body will be in static condition. It will be in rest. Third question: is the turning effect produced by the force on the body on which it acts is the turning effect produced by the force on which act is the moment is also produce the turning effect, and a rotational effect is produced by a turning effect. We can say turning effect of the rotational effect produced by, it nearly answer is couple. Mainly turning effect, if we say turning effect is produced by the moment, and if the point of rotation is fixed, then it will also have a turning rotational effect also. But rotation in the sense the moment gives a clear rotational effect, but when we consider the couple, it gives rotational effect. But moreover, here there is no moment option. Moment option is not there. Then couple will holds good for the is nearly to this answer. So couple is the right answer. Let's check. Yes, couple is the answer. Next question: find the resultant force for this. Resultant force for this figure: 120 kilonewton plus 120 kilonewton in positive plus 120 is if we consider H, 120 kilonewton Newton minus 55 will be equal to 65. Vertical component force will be 70 upward direction, this one 70, and minus 70 downward direction equal to 0. And horizontal force equal to 0. Resultant, if we calculate directly, H square plus V square. H is 65 square, V is 0 square. Then 65 square is 65, and 65 is the resultant force. Yeah, 65 is the resultant force. 65 is the resultant force. Let us see. 65. Yeah, 65 is the answer. Fifth fourth question. The force whose line of action are parallel to each other. 40 Newton and 100 Newton are parallel to each other. 40 Newton and 100 Newton. 40 Newton and 100. 40 Newton and 100 Newton are parallel to each other. We act in same direction, then the resultant force will be, if the two forces are in same direction, then it should be added. 100 plus 40. 100 plus 40 is 140 kilonewton is the answer. Resultant force is 140 kilonewton. Yeah, 140 kilonewton is that. 140 kilonewton is the answer. Let's see. 140 kilonewton. Sixth question. The three forces of 100 Newton, 200 Newton, 300 Newton have their line of action parallel to each other, okay, but the first in opposite direction. First is 100 Newton, which is opposite direction, and 200 Newton and 300 Newton is in same direction. 100, 200, 300. Listen carefully. Observe it. 100 Newton, 200 Newton, 300 Newton are three forces which are parallel forces. All forces are parallel, but the first in opposite direction, each other. But first in opposite. First is 100 Newton. First is opposite direction. The opposite direction, I have written the opposite direction. 100 is minus 100 plus 200 plus 300. Then the cancel 100, 400 plus 400 will be the resultant. First 400 will be the result. Let's take the answer. 600 is the 500, 100, 400. Yeah, 400 is the 400 Newton is the right answer of resultant. Yeah, 400 is the right answer. Move to next. Parallel forces 24 and 20 Newton are acting, and the resultant with respect to like and unlike forces are. Slightly twisty question. 24 Newton and 20 kilonewton are the like forces. Okay, 20 and 20 are acting parallel force. It is not given like for parallel forces 24 and 20 Newton. Okay, are acting, and the resultant with respect to like and unlike forces. Like and unlike forces. Okay, like for first one we'll take like forces 24 and 20, which are like forces. Like forces. Okay, I'll erase it. 1 second, I'll write 1 second. 24 and 20 are like forces, which is in same direction. 24 and 20 like forces. So some adding these two, which is in same direction. If you add this 24 into 24 plus 20 is 44 Newton. When this in unlike forces, when 24 is one direction, 20 is in one direction. 24 and 20. 24 minus 20 is 4 Newton. I hope this would be the answer. 44 Newton and 4 Newton. Like forces, it is 44 Newton, and unlike forces, is 4 Newton. This is option. 10 and 10, no. Yeah, second option is correct. 44 and 4, we have got the answer. 50 Newton, 50 Newton, no. Then obviously, yeah, 44 will be the answer. 44 Newton is the 44 Newton and 4 Newton will be the answer. Next question: in a couple, one of the force is 75 kN, then the other force with the opposite direction will be same. A couple should have two forces which should be equal. Then 25 kN, one of the forces 75 means other force will be also be 75. Yes, 75 option is there. 75 kN, 75 kN is the right answer. 75 kN is the right answer. We have come to end of the session and end of the Introduction to Engineering Mechanics Unit 1 chapter. I sincerely thank one and all to all my viewers and all my guides and all my team members to successfully complete this chapter 1 with the 6 sessions. Thank you one and all.